guys, welcome to another episode of my channel. So today we are going to continue our story about RC522 module. And subject for today is access bits. So this code it's mostly the same as in our previous episode. So with this code we are just going to dump information about our card to serial monitor. And this code is already uploaded to my microcontroller. So I'm going to open my serial monitor. Going to restart my microcontroller, and now I'm going to press my card to my RC522 module. Alright, so subject for today it's access bits. Up to now I explained what is the zero block that contains basic information about your card. Then I explained what are trailers block, and that every sector holds one trailer block or tail block. I heard that expression too. And I also explained that every sector holds data blocks. These card data blocks are mostly empty, so you are going to see mostly zeros. Except this block number 4 that we used in our previous episode, and we fill it with bytes AA. But now we are going to talk about this part. You see this table with zeros and 1 in the corner. This table is actually a representation of access bits, and access bits are regulating read-writing permissions, both for data blocks and trailer blocks. And in order to explain this better, I'm going to open my Mozilla Firefox, and you can look online for this document. It's public document, MF1S50, MyFair Classic EV1Y1K. I'm going to navigate to page 12. So this is really important document if you want to play with RFID cards, with MyFair RFID cards. So page number 12. Okay, first I'm going to explain these two tables. So this is access conditions for sector trailer. And we have table with access conditions for data blocks. These C1, C2 and C3 are bytes in a row that represent access conditions for that particular block. So C1, C2 and C3. Let me show you with my Visual Studio Code. For example, for this block, this first byte would be C1, second would be C2 and third byte would be C3. And now let's get back to internet. What does mean 000 access bytes? Means that both key A and key B could be used for reading, both key A and key B could be used for writing. These both keys could be used for increment, decrement, transfer and restore. And if, for example, you use something like 101, you could use only key B for a reading. So in order to read content from that block, you have to authenticate with key B. But you cannot use that very same key or key A for that matter to write, to increment, decrement or anything else. But you can also set access bits for trailer blocks. Let me show you. This is this table. So for example, in our case, my trailers are set as a 001. But now, in order to write keys, that's completely different matter. Let me show you why. I'm going to my Visual Studio Code once again. So your access bits are presented in this form. But in order to set access bits, you have to deal with these 3 bytes, and these 3 bytes are represented in hexadecimal form, so FF, 07 and 80, and out of these 3 bytes we are getting this table of access permissions. So finally, how to turn these 3 bytes into this table? Let me show you. I'm going to open my Firefox once again, and I'm going to show you this table. So first, what this C1 with index of 3 actually means, or C1 with index of 2. This sign means that we are dealing with first byte in third block, and that third block it's actually sector trailer. So that means that we are counting from bottom to top. block 0, it's actually bottom block, and then we are counting 0, 1, 2, 3, and with 3, it's sector trailer. So in our case, in case of this sector, let me show you. That means that 0 block would be block number 4, and trailer block, it's of course block number 7. And now let's get back to Mozilla. By following rules from this table, we are able to set values for these 3 bytes for access permissions. And how so? Let me show you how to do it, but keep in mind, in order to follow this, you need to understand how to read bytes and how to write bytes, and what complementary bytes are. So basically what complementary bytes are: if you have 0 complementary byte, it's 1, and if you have 1 complementary byte, it's 0. It's going to be important when we set values for these, like C2 with index 3, but complementary one. Okay, so now I'm going to open my Visual Studio Code once again, but I'm going to minimize this. I'm going to open my document. I have one TXT document just for this purpose, and now we are going to calculate value for our access bytes. So what are our access bytes? So we have 001 for trailer, and we have 3 zeros for rest 3 blocks. And now I'm going to make some space because we need to start from bottom to top. So in here we have third block, third byte, it's 1. Then second block, third byte, 0. Then third byte, first block, 0. Third byte, bottom block, 0. Second byte, third block, 0. Second byte, second block, 0. Second byte, first block, 0. Second byte, bottom block, 0. We are going one row up. So now we have first byte, third block, 0. First byte, second block, 0. First byte, first block, 0. First byte, bottom block, 0. Now we have third byte, third block. It's 1 but complementary, 0. Third byte, second block, it's 0 but complementary, 1. Third byte, first block, it's 0 but complementary, 1. Third byte, bottom block, it's 0 but complementary, 1. And top row, second byte, third block, 0 but complementary, 1. Second byte, second block, 0 complementary, 1. Second byte, first block, 0 complementary, 1. Second byte, bottom block, 0 complementary, 1. First byte, third block, 0 complementary, 1. First byte, second block, 0 complementary, 1. First byte, first block, 0 complementary, 1. And first byte, bottom block, 0 complementary, 1. And now if we turn this value into hexadecimal form with all ones, we are going to get FF. If we turn this 3 ones at the end, what we are going to get? We are going to get 07, and with 1 with all of zeros rest, we are going to get 80 hexadecimal. So now I'm going to maximize this window, and I'm going to open main CPP. So I'm going to open serial monitor once again. All right. I'm going to read my card once again. Let's see what we have as access bytes. So we have FF0780. Let's see what we have in here. We have FF0780. So in this way we can calculate values for our access bits. And now let's get back in here. So let's say that I want to deal with data blocks. And let's say that I want to set my access bits to 011. So how we are going to do such a thing? Let me show you. Let's go to this table. This is going to be important once again. I'm going to minimize this once again. we don't need serial monitor. So now what we need? Now we are going to have 001, 000, 000, and we are going to have 011. And we need to turn this into binary values. So once again, we need a little bit more space. And we are starting with our bottom block. So once again, third bit, third block, it's 1. Then third bit, second block, it's 0. Third bit, first block, it's 0. Third bit, bottom block, it's 1 now. Second bit, third block, it's 0. Second bit, second block, it's 0. Second bit, first block, it's 0. Second bit, bottom block, it's 1. We are going one row up. So let's see. First bit, third block, it's 0. First bit, second block, it's 0. First bit, first block, it's 0. First bit, bottom block, it's 0. Now, third bit, third block, it's 1, but we need complementary numbers, so 0. Third bit, second block, it's 0, but complementary, it's 1. Third bit, first block, it's 0, but complementary, it's 1. And third bit, bottom block, it's 1, but complementary, it's 0. One row up. Second bit, third block, it's 0, but complementary, 1. Second bit, second block, it's also 0, but complementary, 1. Second bit, first block, it's also 0, but complementary, 1. Second bit, bottom block, now it's 1, but complementary, it's 0. First bit, third block, it's 0, but complementary, it's 1. First bit, second block, it's also 0, but complementary, it's 1. First bit, first block, it's also 0, but complementary, it's 1. And first bit, bottom block, it's also 0, and complementary, it's 1. And if we turn this value into hexadecimal, I'm going to use my calculator for that. So this is EF. EF. Now we have 6. This is easy to calculate. So 06. And third, I'm going to use my calculator because it's much easier. It's 91. Okay, 91. And now I'm not going to need any of this, so I'm going to expand this window. And finally, I'm going to show you how to set these access bits. Okay, I'm going to make some space. Now, before we continue, I have to explain something. Keep in mind that this is a dangerous process, so you could easily turn your card useless. So you are going to do something like this only if you absolutely know what you're doing. And of course, everything that you do, it's on your own personal responsibility. And one other thing, you are rarely going to need something like this. So in most of cases, you are never going to deal with something like access bits. But anyway, this what we are doing in here, it's for educational purposes only. It's on me to show you how to do it. What you are going to do with this knowledge, it's absolutely on you. So first thing that we need to do now, it's to authenticate. So I'm going to create byte status, and I'm going to use my module pcd authenticate, and I'm going to use our library with key A. I'm going to authenticate with key A on block number 7 with my key A, and I have to provide UID, address of UID, UID. Okay. And now we are going to check this status. So if status not, if status it's not okay, we are going to print something to serial monitor, like authentication error, and we are going to return. All right, now next thing, we are going to create a byte array, like trailer buffer is going to be byte array, and we are going to hard code the content. So first we are going to code the content for our A key, so that is OXFF, and I'm going to copy this 5 more times. Alright, I'm going to make some space, and I'm going to do the same for B key. And in this middle line, I'm going to put content for our access bits. So we calculated EF0691. EF0691, and I'm going to set that fourth bit to 00. If you read documentation, you are going to see that this fourth bit, it's actually data bit. You could use it to store your data in it. So it's completely unimportant for this purpose. But in order not to break anything, I'm going to set it to 69. That is default value for my card. Alright, now I'm going to use this status again, but now with another function, myForWrite. So first argument is going to be a block where we want to write. We are going to write to our trailer block, and we are going to write our trailer buffer, and our buffer size is 16 bytes. And I'm going to use this piece of code in order to test everything. Let's see. But now we are going to have writing error, and I want to dump everything to serial monitor. Alright, I'm going to build this code. I'm going to upload it. Alright, and let's see what we did. I'm going to reset my microcontroller, scroll this down, and now I'm going to press my card to my RC522 module, and let's see what we are going to get. Okay. So our data, it's successfully written to our data bits. You see here with block number 11 we have old value FF078069, and with block 7 we have EF069169, and we read everything up to block 4. For block 4 we don't have reading permission. And finally, in order to show you that my card is still operational, I'm going to change this code into old values. So let's see what old values are. So we have FF0780, FF0780. Everything else is going to be the same. I'm going to build this new code. I'm going to upload it. Alright, and now I'm going to open my serial monitor to reset my microcontroller, and now I'm going to press my card again. Wonderful. So as you can see, we can read the values from our block 4 without any problems now, and now our access bits are back to original values. So guys, that's all for this episode. I hope that you learned something new and something interesting, so please like, subscribe, and see ya!